Hey guys, so today we're going to be looking at Mafs.8.G.2.6, which is all about the Pythagorean theorem. So we're going to be taking a look back at the Pythagorean theorem and really diving into how to make sure we understand where the Pythagorean theorem comes from. So this week you will have your final two standard checkpoints. These will be the last two grades of this year, so make sure that on Wednesday and Friday you are getting those checkpoints in. So this diagram is actually where the Pythagorean theorem comes from. So if we have a right triangle, okay, so if we have this right triangle, if I take this leg, which is 3, and I square it, so 3 times 3, which is 9. And if you count, there's a total of 9 blocks here. And if I take my other leg of my right triangle and I square that, so 4 times 4, that's 16. There's actually 16 blocks here. Well, what Pythagorean theorem tells us is that if I square the two legs of a triangle and add them together, I get our hypotenuse. And that hypotenuse is across from your right angle. So let's test that out. If I square 5, so 5 times 5, there's 25. And I would encourage you to pause the video and count up all of these blocks. There's 25 blocks there. So if I add a squared, which was 9, and b squared, which was 16, it equals 25. So if I actually took this side, all these blocks, and added them to all of these blocks, they would actually fit over on this side. That's what Pythagorean theorem tells us. So in the next couple of slides, we're going to be practicing that idea. So number 2 says, which of the following 3 numbers are also the sides of a right triangle? Well, in order to be a right triangle, a squared plus b squared equals c squared. So if we try that with a, and I know what you're thinking, well, how do I know which one's a, which one's b, which one's c? Your c value, grab a highlighter here, is always going to be the largest number. Okay, so out of that set, 2 would be the largest. Out of this set, 4 would be the largest. The square root of 2 would be the largest. And then here, 3 square root of 3. Let's check that out. So if we square root 3, is that going to be the largest? So if we square root 3 times 3, no, so actually here 6 would be our 2 longest sides. So this triangle can't even work because it doesn't have a longest side, because 3 times the square root of 3 is only like 5 point something, and we know that's not bigger than 6. So let's try A. If I square 1 and add it to 1 squared, so 1 squared is 1, 1 squared is 1, 2 squared is 4. These two sides are not equal. So A is not true. Well, what about B? So this would be A. If I test B out, 3 squared plus 3 squared equals 4 squared. 3 squared is 9. 4 squared is 16. So if I add these, 18 does not equal 16, so B can't work either. So let's try out C. If I square 1, I add that to 1 squared. 1 squared plus 1 equals, when you square a square root, remember that number just pops right out. So 2 equals 2, my answer would be C. All right. So when you're trying to test the Pythagorean theorem, a squared plus b squared equals c squared. Number 3, why is the converse of the Pythagorean theorem equally as important as the Pythagorean theorem itself? So go ahead and take a moment and read through those. So the reason it's super important is because it allows us to identify right triangles. So if a squared plus b squared actually equals c squared, then we have a right triangle, which is what we did in number 1. So in order to be a right triangle, a squared plus b squared has to equal c squared. All right, let's look at this next set of problems. It says that we found the equation 8 squared plus 15 squared equals 17 squared is true. What does this mean? So go ahead and read through those, A, B, C, and D. What does this mean? So what it means is that if the sides of a right triangle have a length of 8 and 15, the hypotenuse is 17. So if we squared 8, squared 15, and added that to 7, if we took 8 squared, added that to 15 squared, we should get 17 squared. All right, so looking at this last one here for this video, which of the following are possible side lengths for a right triangle? Justify your answer. I want you guys to do the same thing we did in that last slide. Filling out a squared plus b squared equals c squared. Which one of these would work? So go ahead and pause, work this out, and then see what your answer is. Okay, so let's go ahead and show this work. So for A, 1 squared plus 2 squared, does that equal 3 squared? Well, let's try that out. 1 plus 4, does that equal 9? No, A is not going to work. B would be 3 squared plus 5 squared equals 7 squared. So 9 plus 25 equals 49. No, that's not going to work either. What about C? 6 squared plus 8 squared equals 10 squared. So this would be 36. Oops. 36 plus 64 equals 100. Hey, that works. 100 equals 100. So C is our answer. All right, so on the next video that you will watch tomorrow, we'll be diving a little bit more into Pythagorean theorem and looking at some distance problems, which are very important. So please make sure that you watch that video. Have a great day. Goodbye.